This is the final functional demo of our CubeSat flight computer and radio and ground station. So here, right now, I'm in the ground station, and you can see that we're getting telemetry from each of the four sensors on the spacecraft. So the accelerometer, the gyroscope, the magnetometer, and the temperature sensor. And then you can also see an image that I downlinked earlier, and it's pointed at me, so that's me. And the status of the various connected radios. So here we can see this image was downlinked, 350 seconds ago, and our command issuer here. So to show you the telemetry updating, I'm going to walk over to the satellite now, all the way on the other side of the room. And what I can do is I can kind of shake it a little bit to induce some rate changes and some accelerations, and then I can also rotate it, which will change the magnetic field, how it is relative to Earth's magnetic field, and that'll show up as well. And then I can go back to the ground station all the way over here, and we can see that when I shook it, that shows up on the accelerometer and the gyroscope, and then also you can see me moving it in the magnetic field display. There was a slight temperature drop as well, but there's not going to be a whole lot of change here because it's a highly inertial system. But you can see it's about 25 degrees in this room right now. So to demonstrate command uplink, I'm going to send a command to the spacecraft, and what it's going to do is it's going to take an image and then send it over to me. And I have 3 resolutions to select from. I'm going to go for 160 by 120 to start, just so you can see what that looks like. So the command's been sent out to the spacecraft, and then in a few seconds it'll start sending it to me. So here we go, we're getting image packets now. You can see there's a few errors, but overall not bad. This uses 2.4 gigahertz, which is kind of noisy inside buildings due to Wi-Fi and such, but overall pretty good image quality, not too many dropped packet errors. And it looks like the image has finished downlinking. And then now it's going back to streaming telemetry. So I'm going to actually do a 320 by 240 image now. And then as I do that, I'm going to walk over so I can show you the actual satellite. So we're going to issue that, send it out. Just make sure that it got it, and it looks like it did. Starting to send. So over here on the actual spacecraft, you can see we have on top the radio board, and you can actually see the activity light on the S-band channel is on because it's actively sending packets over S-band. So here we have an S-band antenna, which is just an off-the-shelf like Wi-Fi antenna, and then a dipole for UHF that I made myself. The entire radio board was also made by me. You can see my name right there. Done in KiCad, ordered through JLC, and hand assembled and soldered in a toaster oven. And then down here, we also did have a flight board. Unfortunately, we were not able to get it ready in time for the demo, but we have our Nucleo board here, and then a little breakout we made that has all our sensors on it, and then some USB power that we basically break out from this battery pack. And then here's how we actually connect the harness to the spacecraft. Originally, there was actually going to be there is a complementary port for this on the flight computer board, but sadly the flight computer board is not here. But the functionality is identical. So looks like it's still transmitting, but we can go back over to the ground station to see how far it's gotten. And then this is kind of my setup for receiving. Looks like it actually just completed because we are receiving UHF telemetry again. So you can see right there, I'm going to rotate it. The camera is 90 degrees rotated, but you can see there's me. You can see me holding the phone and actually commanding it to take the image. And then you see some telemetry as well. So it's streaming at about 2 to 4 hertz. And there is actually error correction as well for telemetry packets. So we can scroll back up here. You can actually see it says my timestamp checksum failed. And then it tells me 2 telemetry data points failed to parity check. So it's important that we have that for telemetry, because ultimately in a real satellite, you would use that to make decisions about, command and control. So you want to make sure that that data is good, which is why we have these checksums and parity checks here. And then if you walk back over, the way we can tell that it's sending UHF telemetry is because the activity light here blinks on and off every time it sends a packet. And the activity light on both buses is just connected to SPI MOSI pin. And so in terms of architecture for the radio board, we use an off-the-shelf UHF module here that's controlled by this onboard microcontroller. And then for the S-band, we use a custom system that I designed. So we use an off-the-shelf Texas Instruments transceiver, and then custom front end. And we use the same type of microcontroller as we use for UHF. And these have FRAM on them, so they're radiation resistant, and they can store values, store basically their memory, power down, power back up, and still have it preserved. So it's non-volatile RAM, which is really nice in an application where you have watchdog timers that might expire, but you still want to preserve the data. And here we have a Nucleo. I forget the exact number of this chip, but it is also spaceflight heritage, which is very good. So a lot of stuff in this project is spaceflight heritage. Same thing with the UHF module that has been used on PyCubed, among other CubeSat projects. Anyway, thank you for watching.